Hello and welcome back to another episode of my world map tutorial series. In the last episode we added the player icon to our map and made it update when we're moving around and jumping. Today we will talk about zooming in and out using the mouse wheel. So the basic idea behind zooming in and out is simply that we will increase the size of our world map here, currently set to 1080 by 1080, and if we were just to increase that by a bit, this would be how we want to handle zooming. Let's reset that. Of course we want to do that in script. So let's compile, save and close the main widget. All of the functionality should be put in our map component. So under actors, BPC world map. And from the last episode, you remember we already created the original player size. Let's do the same thing for the map size. So let's add a variable called original map size. And let's make that a vector 2D. Because you could be using images that are no squares for your map. So for that cases you have access to X and Y separately. And let's make that private. Same as with our original player size, we want to set this variable when we initialize this component. So go to your event graph and to the initialize map event. Right here we are setting the original player size. Let's add a bit of space here and set the original map size. You can right click the variable here and split it so you get access to X and Y, or we can reset that and simply drag out of it and make a vector 2D. So hook that up to the execution. Like with the player size, we have two variables in our map reference, so map size X and get map size Y. Let's hook both of them up to the make vector. With two variables for the original size of map and player, we want to add another variable. And with that, we want to keep track of how much the size is modified currently. So we will just call that the current size multiplier and make that a float, private. Let's compile and save. And by default, it is 1. If this was 2, our map would be double sized. And 0.5 would mean half the size of the map is currently displayed. Then let's add a function to modify this multiplier. And we will use the same function for zooming in and out. Just call that modify map size. And let's give this one input of type float, which will be the multiplier. First off, we only want to allow multipliers that are greater than 0. So something like -1 will simply be ignored. Let's look for greater or equal to 0 and add a branch. If it's false, we can directly return. But if it's true, let's set the current size multiplier to the current size multiplier times float, and then hook up the multiplier from your input. Connect your multiplication to the set node. So that way we already updated the current size multiplier. To see the size change, we need to get the map reference, and there is a function we created called setMapSize there. Now to figure out to X and to Y, we get the original map size and multiply that by a float, which will be the current size multiplier. Then we can break it to get X and Y. And it's expecting integers here, so let's round both values. All right, let's copy the round node for Y, and let's hook them up to X and to Y. After that, we can also return here. Let's compile and save this function, and we can close it and head back to our event graph, because here we will add another custom event called onInput modify size. So this would be called when we scroll up or down using the mouse wheel. And this also needs two inputs. First one would be a boolean called increase. So are we zooming in? If so, that would be true, if not false. And the second one will be an integer called %. For example, if this integer was 10, we need to zoom in by 10%, and that way we would modify the map size by 1.1. First off, we need to see whether our map is actually visible, otherwise we won't zoom in or out. And if it's true, let's call the modify map size function. Then we've got to do a little bit of math to get the multiplier. Let's look for float plus float. and type in 1 here for the first one. Then for what we want to add, let's look for a select integer node and hook up the increase as pick A. If we're increasing, we're using 1. If not, we'll be using -1. Then we want to multiply that by another integer. Off of our percentage, let's clamp that from 0 to 100. Then let's convert that to a float int, divided by another float, which will be 100, and multiply that one here by another float. And here we want to hook up the return value of our select int node, so we can actually remove the int multiplication. We will rather work with floats. Then we can simply plug that in for the add node here, 1+, and hook that up to the multiplier. So for example, if increase is 2 and we want to increase it by 10%, the multiplier would be 1 plus 10 divided by 100, so 0.1, times 1 because we're increasing. So 1.1 would be the multiplier. If we're trying to zoom out, so increase is false, and we're using a % of 10, that would be 1 plus 0.1, but this time multiplied by -1, so minus 0.1, and then the multiplier would be 0.9. Now we want to set up an input to actually call this event. Let's close our map, and we want to do that in our third person character. Open Blueprint Editor. We can simply right click and select a key. In general, the mouse wheel is used for that, so let's look for mouse wheel up and look for mouse wheel down. Then simply drag in your player map and call on input modify size. Hook that up to the pressed of wheel up, and same thing goes for our pressed of wheel down. Connect the map as the target. So when we scroll up, we want to zoom in, so increase would be true. And let's say we zoom in by 20%. Then if we scroll down, increase would be false, and we zoom out by 20% too. Okay. If we compile, save and play, we can hit M to show our map. Now I'll scroll up and the size increases here. I can scroll down and it's getting smaller again. However, an issue that you're noticing right now is that the player icon here is set off until we move, then it would be updated. The reason for that can be found in our BPC world map. If we have a look at update player position on map, we are using location to map position. And here we are accessing the map size in X and map size in Y. So these two values are changed when zooming in and out, but we're not calling this function again to update the player position. That is why this issue is caused. It's very simple to fix. We simply go into modify map size, and right here before the return node, we will call update player position on map. If we compile, save now and play, hit M and zoom in and out, you see that the position stays the same. However, you will notice that the size of the player icon actually is not adjusted when zooming in and out. So that means when we zoom out, the player icon appears to be too big, and if we zoom in, it appears to be too small. Sometimes you actually want to keep that behavior, but let's say we want to make this a setting. So let's add a variable here called keep player size when zooming, ? And to really make this a setting that you can set when selecting this component, we want to make it editable, exposed on spawn, put it in the settings category, and compile and save. I'll set the default to false. If you want to keep that behavior, set it to true. In our modify map function, right before we update the player position on map, let's add a branch or an if statement and hook up that newly created boolean. So keep player size when zooming. If it is true, like you've seen before, we can simply go into the update player position on map and return. But if not, we will get the map reference and call set player size. All right, hook that up to false. Then to figure out to X and Y, we simply get the original player size and multiply that, vector times float. Hook up your current size multiplier, break the result, and round the two values, so round X and round Y. Then hook them up to X and to Y. And after we've set the player size, we can go into the update player position on map and return node. Modifying the player size also means we have to go into the update player position on map, because right now we are only using the original player size for the widget size input. However, if that key player size boolean is false, the original player size is not necessarily the actual player size. So let's look for a select node here and plug in key player size as the index. If it is true, we can always use the original player size, and if not, we want to multiply it by a float, which will be the current size multiplier, and hook up the result to false. Then the return value can go into our widget size. Let's compile, save, and playtest. If I hit M, we can see our player. I can zoom out. Now you see that the size is adjusted properly, and if I zoom in, he will appear large again. Another thing right now is that we can zoom in and out infinitely. So that is a problem. Usually there are certain limits that you can reach when zooming in and out. So let's also implement that. Just to make sure our map does not become too small or too big, let's add one variable called minimum zoom. And this will be a float. Basically, it's just the minimum value that the current size multiplier can reach. We can make this a setting, so editable, exposed on spawn, and in the settings category, add another variable called max zoom. And same settings here, so editable, exposed on spawn, and settings category. Compile, save, and you can set up some default values. Let's say I want the minimum zoom to be 0.5, so half the size of the original map, and the maximum to be 2, so twice the size of our original map. To have these variables actually do something, we'll go to modify map size, and right here, let's add a bit of space to the right. Once we've multiplied the current size multiplier by the input, we want to clamp this value, clamp float, to the minimum zoom as min and maximum zoom as max. And the return value will replace what we are currently using for the set current size multiplier. Alright, compile and save. If we play again and hit M, we can only zoom in that much and zoom out until our map is that small here. Also, these settings are easily adjustable. If you just have a look at your third person character in the level, you could select the player map and, for example, change the maximum zoom to 8, and then you're able to scroll in a lot more. Let's reset that to 2. The last issue that we can see is that if we zoom in, we can't see everything of the map. So we want to be able to move this map around using the left mouse button and dragging. The way we want to achieve that is if we have a look at our W world map, we've got the map overlay here, and if we play around with the translation here, you can see how we can move this around. So that is what we want to do in code. But first off, let's implement a check to see whether the map is too big for our current window. And let's do that in the BPC world map. We want to add a function called map out of boundaries. It will have one output of type boolean called out ? And let's make this a pure function. Then you can get your map reference and call get desired size. Alright, so this is the size of the map. And we want to get viewport size. We want to break both return values here. And the map is out of boundaries either if the size in X of our map is greater than the viewport size in X, or if the size in Y of the map is greater than the viewport size in Y. So drag off your X and look for greater, float, hook up the X of the viewport, and then we'll connect that with an OR boolean. And the second condition will be that the Y is greater than the Y of the viewport size. Hook that up to the OR and the OR to the output. Compile, save. Then we can hop back to our W_world map, and we only want to move this map around when the left mouse button is down. So let's go to the graph and add a variable here called lmb_down ? By default this would be false. And then we'll go to functions and here to override, look for on mouse button down. So this event is called when the mouse button is down while hovering over this widget. And we only want to recognize this when the left mouse button is not already down. So we'll drag that and look for a not. If it isn't down, we want to check whether it now is. So let's add an end boolean, and off of your mouse event, call is mouse button down. Mouse button would be the left mouse button, unless you want to use the right mouse button for dragging. That's also fine. Hook that up to end. add an if statement, hook that up to the execution. If it is true, we can set LMB down to true and go into a return node. When overwriting this function, you'll get a warning if you're not returning something. So off of the return value, let's look for handled. So this widget handled the on-mouse button down input, and that way it won't be passed on to other sub-widgets. If it's false, we can also just return with handled. Okay. We also want to be able to release the mouse button and stop dragging. So override on mouse button up. Let's add a branch and plug in LMB down. So if LMB down is true and we're releasing a mouse button, we'll just set it to false and go into a return node, then look for handled. But if it is false, we can also return, but this time we didn't do anything, so unhandled would be what we want to return. Last thing that we want to override is the on mouse move. And there are two conditions that we need to check when moving the mouse, figure out whether we actually want to move the map. So let's add a branch. First off, the left mouse button has to be down and our map has to be out of boundaries. So under components, you've got your map reference, simply call out of boundaries and hook that up to the end. Then the end will feed into the condition. Let's do false first. So if any of these conditions is false, we will return with unhandled. But if both of them are true, let's add another branch to see whether our mouse was moved. So off of the mouse event, get the last screen space position and get the current screen space position. So just get screen space position. And we want to compare these two. Off of one of these, look for double equal and hook up the screen space position, then connect that to the branch. Basically what we're checking here is whether the mouse was moved by more than the error tolerance here. The true path means it wasn't really moved, so then just return with handled. And false means it was moved, so then we can grab our map overlay and set render translation to move it. And then we need to figure out the translation. So actually what we want to do is always add something to the already existing translation. So grab your map overlay, get the transform and break that. Then you've got access to translation, scale, shear and angle. Let's expand the transform here. We only want to use translation. And off of it, we want to add a vector to this. And now we have to figure out by how much units our mouse was moved. Let's drag off our mouse event, get the screen space position. And off of this, we want to subtract the last screen space position and hook that up. Our result is how much units the mouse was moved after the last time that the space position was checked. And we can hook that up to the add node to the new translation, and then also return with handled. Let's compile and save. One problem right now is that we only implemented the on mouse button up in the world map. And if we have a look at our main widget, it could be that we start dragging in the world map widget here, but then release maybe here, and that would no longer be registered by the world map because it's outside of the widget boundaries. That means we have to go into our w_main to the graph and also override the on mouse button up here and simply grab your world map and set LMB down to false. After that, we can return and plug in handled. Right now, that wouldn't do anything because in our main widget, there is no element that detects mouse input. So what we have to do is go grab our canvas panel and set the visibility here to visible. So the mouse cursor will hit it. Compile and save. If we then play, open up our map and zoom in until it's out of boundaries, we can hold down the left mouse button and move our mouse to move the map. So that is working fine. One issue though is if you move it maybe to some of the corners, lower left corner right here, and then if you zoom out again, you see that our map is no longer positioned in the center of the screen. So let's fix this. We'll go to our BBC world map and we only want to reset it back to the center when zooming out. So that could be done in our event graph. In the on input modify size. After we modified the map size, we can add a branch off of the input increase. And only if it's false, we are zooming out. Then we can simply grab our map reference, grab the map overlay, and set render translation of that. Hook that up to false. Then off of your map reference, get the transform, break it, only show the translation. And we want to slowly reset that when zooming out. So we will simply multiply that by a float, which will be the current size multiplier, and hook that up for the translation. Compile and save. If we test one last time, open up our map, we can zoom in, actually move the map, and that will also update fine when moving around or jumping. And if we scroll out again, it will be reset to the center. Alright, that's the end of this episode. Next up, we'll be dealing with placing markers on our map. See you then.